Hello and good evening, ladies and gentlemen, and welcome to the November Recreational Astronomy Night of the Toronto Centre of the Royal Astronomical Society of Canada. My name is Tom Luton. I'll be your host this evening. Tonight's presentations, we've got Arnold Brody doing the sky this month. We have Chris Vaughan talking about adventures at the Eyepiece, my journey through RASC's visual observing programs and beyond. We've only got two speakers this evening, but both of them will be going longer than normal, so we'll still be getting out at around the usual time. We're online only tonight, unfortunately. Fortunately, because it's pouring rain here in Toronto. We've got some technical issues that we've had to resolve, and we're putting new equipment through its paces. So hopefully we'll be glitch free this evening. Anyway, so without further ado, we're going to be moving on to Arnold Brody in the sky this month. Arnold, take it away.
Thank you, Tom. And hi, everyone, and welcome to the sky this month. We'll look at the stargazing highlights from tonight till December the 2nd, the night before our next monthly meeting. And I'll be showing you the night sky as seen from Toronto. As for the highlights, tonight's full moon is a supermoon. Tomorrow evening, the moon visits the Pleiades. This coming Sunday, Pollux, the moon, and Jupiter rise aligned. Monday morning, November 17, is going to be a busy one. It's the peak of the Leonid meteor shower, one of two mornings for the meteor shower peak. And at the same time, a thin crescent moon rises next to Spica. Uranus reaches opposition on the 21st. The following Friday, the modest November Orionids peak. You'll find Saturn rising 4.5 degrees from the moon on the 29th. And on the following night, there's a double occultation of stars in Pisces. In addition, there are 3 comets that you can hopefully find, and all 4 gas and ice giants are up in the night sky this November. Meanwhile, the long nights of mid-autumn offer excellent opportunities to hunt down deep space targets. So this coming month has everything you might want to ask for: planets, comets, meteor showers, deep space, a double occultation, and some close encounters with the moon. And all we really need are some clear skies. I like to combine astronomical twilight, when planets and bright stars can be seen, with night and call it the observing window. In November, the window is almost as wide as it gets, as you see here. And while it's the opposite, of course, for those in the southern hemisphere. Now, for Toronto and similar latitudes, the observing window tonight is almost 12 hours long and over 12.5 by the beginning of December, when true night is 11.5 hours long. The moon is full tonight and reaches last quarter a week from tonight. New moon, what I like to call no moon, occurs on Thursday, November 20. Many of the sky scenes I'll be showing you will be during this time period in and around the new moon. Now, the first quarter then is on the 28th, and the full moon goes by a number of names, such as the beaver moon, the deer rutting moon, digging scratching moon, freezing moon, frost moon, the whitefish moon. So let's begin our tour of the night sky with a look at the inner solar system. The inner solar system planets hover near the sun this month, making them hard or impossible to see. Basically, this is not a good month for observing Mercury, Venus, or Mars. Many have single-digit elongations from the sun. After passing inferior conjunction on November 20, Mercury might be possible to catch just before sunrise. Tomorrow morning, Mercury is already a difficult catch, and it's diving down to pass in front of the sun on the 20th. Mars is also diving towards the sun to pass behind it on January 9. It's already unobservable. By December 2, speedy Mercury has reached 19 degrees elongation from the sun and might be observable around 6:30 in the morning, but it'll just be 6.7 degrees up and around magnitude 1 due to air mass, so I don't think it's going to be easy. Here's an overly optimistic suggestion as to how the 42% illuminated Mercury would appear with 480 times magnification, but I don't know. It might be optimistic, too optimistic. Venus is diving behind the sun and is already a difficult catch. Venus is just emerging from behind the sun by early December, but still lost in the sun's glare. We'll need to wait until February for Venus to be noticeable as the evening star, so basically the inner solar system is a no-show this month, but not so with the outer four. The outer solar system planets all have elongations greater than 90 degrees, so they are on the opposite side of the sky from the sun and inner planets and are visible at some point of the night. Jupiter is west of the sun, so it will rise sometime after sunset. Uranus rises around sunset all month as it passes through opposition on the 21st. Neptune and Saturn appear very close to each other. There are a little over 4 degrees of elongation separating these two planets, so they will appear very close together in the sky. And being east of the sun, they will be well positioned in the western sky for observing as soon as the sky darkens. You'll have no trouble finding Jupiter hanging out with Pollux of the Gemini twins. By mid-month, Jupiter is rising about 5 hours after sunset, shining around magnitude -2 when you factor in our atmosphere. Jupiter enters retrograde motion on November 11. It ends in late March 2026 with the opposition occurring halfway on Jan 10. Now, any size telescope can show you the equatorial belts and the 4 Galilean moons, especially as Jupiter begins to grow in size on its way to opposition. Light blue or light green filters will darken the rusty colored cloud belts and the giant red spot, making them easier to see. Congratulations to Nishat Khan for capturing this outstanding video of a double shadow transit cast by Jupiter's moons, Io and Europa, back on October 4. Claudio Oriani alerted us of this opportunity in his October Sky Talk last month. There is a strong 3D effect as speedier Io overtakes Europa. And you also have the giant red spot rotating into view, so this is an awesome video. Congrats, Nishat. And Nishat and other astrovideographers out there, there's another double shadow transit coming up on the night of the no moon, November 20. The double transits will already be underway as Jupiter rises into the night sky. So good luck. Maybe we'll see another video posted. You can find Uranus 4 degrees southeast of the Pleiades. Here we see it on the night before its opposition when the moon is new. Being brighter than magnitude 6, people with good vision should be able to spot it on a moonless night if you're far from light pollution. Start the challenge by finding Uranus in binoculars. You'll know when you find it. It's obviously blue and has a disc shape, not like a scintillating star point. By magically erasing all stars dimmer than magnitude 6, we're left with 3 with magnitudes similar to Uranus. Now, keep your head and gaze stationary and slowly lower the binoculars and find these 3 stars. The bottom left star might be too dim to see, but if you can see the other 3 dots, the one in the middle is Uranus, and that would be this one right here. Saturn and Neptune can be found near each other in the southwest after nightfall. Saturn's magnitude 0.87 butterscotch dot is 6 degrees below the circlet in Pisces. And as we saw earlier, Neptune is found around 4 degrees east of Saturn. Saturn's retrograde motion, which began in mid-July, will end on November 27. Saturn will then start drifting westward against the background stars. And we can still catch Saturn due south as it crosses the meridian around 8 p.m. Both planets will set around 2 in the morning. Saturn's rings have narrowed again since the ring plane crossing back in March. The tilt had grown to 3.5 degrees back in the summer, but has narrowed again since, down to a slender 1/3 of a degree, making the rings very hard to see, while making its moons easier. The narrow rings make Saturn's dot in the sky dim, since the rings are reflecting back virtually no light. When they're nicely tilted, they can reflect back as much light as the planet itself, making the dot in the sky appear that much brighter. Right now it's kind of dim, but you can still find it. Now, it says here that you can use a light yellow filter to improve contrast in Saturn's rings, but right now we can't see the rings, let alone improve contrast in them. But maybe a greenish filter will help with the cloud bands, make them stand out a little bit. With your telescope aimed at Saturn, you can find Neptune by slewing 3.4 degrees east and 2.6 degrees north. And you'll know when you find it when you spot a blue dot halfway on a line connecting 3 stars of similar or less brightness. The line makes a stubby off-center T with a 4th star. So if you can find that arrangement of stars, then you'll know that Neptune is this blue dot here, halfway along this long line, and it's going to be obviously blue, and you should be able to see its tiny disk shape as well. As for the comets, there are 2 in the west and north that should be within reach of backyard telescopes this month. Unlike the typical scenario of comets hugging the horizon near the sun, Comet C 2025 R2 Swan will be found hovering in the west, while C 2025 K1 Atlas slices through the circumpolar region. Comet C 2025 R2 Swan is a long-period comet discovered on the 11th of September 2025 by amateur astronomer Vladimir Bezugli, who was studying imagery that was captured by the SWAN instrument, which is in space on board the Soho spacecraft. The comet reached perigee just a couple of weeks ago on October 20 and is now receding away from us, as you can see with the spacing of its daily movement in the sky. The wider spacing you see early here, these are dates in November, 13, 14. They become tighter and tighter and tighter and closer as SWAN recedes away from us. The comet's light curve shows it peaking at perigee and dropping off quickly since. It should be visible in binoculars now, but I'm not sure for how long. Its light curve is dropping quickly, and it should, however, still be a relatively easy target in telescopes. The most common gases detected in the comet's coma include diatomic carbon, amino radical, and atomic oxygen. Comet C 2025 K1 Atlas is visible now. For the first 3 weeks of November, you'll need to be out a few hours before sunrise to observe the comet as it heads northward through the zodiac. But by the 21st, Atlas will enter the circumpolar region, and you'll be able to observe it after dinner instead of before breakfast. The comet is predicted to hover around 11th magnitude, requiring a telescope to see. The comet came from the Oort cloud, which is a sphere 2,000 to 200,000 astronomical units from the sun. So comets that are dislodged from that spherical cloud won't have a bias for the ecliptic plane, and they can travel at steep angles to the ecliptic and pass over the polar region like this one. The comet came within a third of an AU of the Sun, almost as close as Mercury, and beat expectations many had that it wouldn't survive the encounter, but it did, re-emerging on October 18. Spectroscopic analysis of the comet's coma show it to be depleted in carbon cyanogen compounds and has low dust to gas ratio. And those are characteristics observed twice before from Oort cloud comets and are likely the result of not receiving much radiation from our sun for billions of years, for virtually their entire lifetimes. Closest approach to Earth will be on Tuesday, the 25th of November, 2025, at a distance of 60.3 million kilometers or 0.4 AU. 0.4. Now, notice how much the comet travels per night during this perigee. And here are the dates again. Here's the 25th, 26th, and so on. And you can see that there's quite a gap between each dot for each day, for each night. So it is moving across the region quite quickly. C2025K1 is traveling at 50 kilometers a second relative to the sun on a hyperbolic orbit. And that means it will escape our solar system. November and December present your best prospects for seeing the headlines-grabbing comet 3I Atlas as it reemerges from behind the sun, low in the dawn. The interstellar visitor brightened unexpectedly to 11th degree magnitude as it passed perihelion just days ago on October 29. If it remains that bright, it will be visible in backyard telescopes as it moves through Virgo and Leo, as it climbs even higher into the pre-dawn sky. Now, how long it remains bright enough to see in telescopes is questionable, because the comet is rushing out at 200,000 kilometers an hour, or 61 kilometers a second. With an eccentricity of 6, its path had very little bend as it cruised past the sun. In early 2026, the comet will enter Gemini and exit the solar system in the direction of the star Zeta Geminorum, resuming its long journey through deep interstellar space. The comet is rich in carbon dioxide and contains a small amount of water ice, water vapor, carbon monoxide, carbonyl sulfide, cyanide gas, and atomic nickel vapor at concentrations similar to those seen in solar system comets. Now, many of the headlines were over speculation the comet had non-natural alien origins, thanks to an article by Harvard University science professor Avi Loeb, who brought up the suggestion. Meanwhile, a chorus of professional astronomers disagree, saying it looks like a comet and is behaving like a comet. And if you could get close enough, it probably tastes like a comet. In fact, 2 European Space Agency spacecraft have. The Hera craft passed through the ion tail between October 25 and November 1st. And their Europa Clipper is doing the same from October 30 to tomorrow, November 6. These were unplanned but scientifically fortunate opportunities, and it will be interesting to learn what they detect. November is a busy month for meteor showers, starting with the south and north Taurids, 2 meteoroid streams deposited by 2P NP. The south Taurids peak tonight, but with the biggest, baddest full moon of the year tonight, most of those meteors will be washed out. But maybe we can catch a few later since we remain in the meteor stream the rest of the month and into December. The North Taurids peak a week tonight when the moon is third quarter rising at midnight. And because the radiance of these showers rise early in the evening, you don't need to wait until late at night to see them. The 2 Taurids are among the slowest of meteors and can produce fireballs. 1 week later again, on the morning of November 17, as well as the morning of the 18th, the dependable Leonid meteor shower is peaking, producing around 15 meteors an hour. In Toronto and at similar latitudes, we can hope for 9 an hour, and that's a good number. The moon will be nearly new, staying out of the way until nearly sunrise, so that's great. The debris stream left from 55P Temple Tuttle slam into our atmosphere at a fierce 70 kilometers a second, and that can produce very bright meteors. The North Orionids is the last meteor shower to peak this month, which is on November 28. By midnight, when the shower's radiant is high in the south, the first quarter moon will be setting. This is a minor shower with a ZHR of only 3. If you're stargazing on or around the 28th and spot a meteor, trace its path backwards to see if it takes you to Orion. The much anticipated Geminids, with a generous zenith hourly rate of 150, arrive on November 19 and remain active up to December 24th. Now, the peak won't happen until mid-December, when the moon does not rise until 2:30. Bright, colorful meteors may streak across your sky in the second half of November. This shower is unusual in that the debris was left behind by asteroid, not comet, but asteroid 3200 Phaethon, whose orbit crosses Earth's and is considered a potential threat. Phaethon is not an icy body. Its water has combined with other molecules to form phyllosilicate and carbonate materials. When heated to 800 degrees Celsius by the sun, these carbonates release carbon dioxide gas, while the phyllosilicate give off water vapor, and sulfides in the asteroid release sulfur gas. And these gases exert pressure on rocky material, producing small cracks and small pieces and dust particles that the gases lift off from the asteroid. As for the sun at local noon drops by 6.16 degrees over the next 4 weeks, while Earth nears its perihelion in early January. Earth's orbital speed is increasing as we head towards perihelion, while our rate of rotation is constant, and this causes the sun's position at 12 p.m. to drift eastward each day on its way to forming the analemma. The sun is still active. Solar cycle 25 may have peaked earlier this year, but eruptions and CMEs have been detected on the far side of the sun. Coronal holes have also developed, allowing the solar wind to come racing out, producing auroras here. These holes are also linked to the unstable magnetic fields. There is a correlation. These videos were produced by the LASCO C3 camera also on board the SOHO spacecraft. It shows massive ejections released on the far side of the sun from active regions, such as 4246 that were previously Earth-facing, but still going strong. Now, will these regions still have bullets or be shooting blanks by the time they face us again, which is beginning now? So keep monitoring your favorite aurora forecast sites, because we might have some activity the first week or so of November. The moon tonight coincides with perigee, making this a supermoon, the second and closest of 4 consecutive supermoons that occur in a series. This is generating significant king tides along coastlines. The last quarter moon is a week from tonight on the 12th. When the moon reaches new on the 20th, it also reaches apogee, making this a micromoon and the smallest micromoon of the year as well. First quarter is on November the 28th. And on December the 2nd, the moon is just days away from being a supermoon again. One of the month's highlights mentioned at the start is a double occultation on November 30, when the moon passes in front of 62 and Delta Piscium, just 34 minutes apart. 25 Pisceum is probably too dim to see naked eye, but Delta at magnitude 4.4 should be visible from a fairly dark site. That star is a red giant that has drifted off the main sequence. Delta Pisceum is a double star, but its companion at magnitude 14 is too dim to be seen in amateur telescopes. Now, for us in Toronto, the first occultation is 5 seconds before 8:20, and then it occults Delta Pisceum. Now, after the occultations are over, keep your telescope focused on the moon. There's an interesting crater catching sunrise and is prime for exploration. It's crater Gassendi, one of the targets in the Explore the Moon observing program. Gassendi is a 111-kilometer circular crater with unusually low walls. That's because the crater was flooded by lava when a monster asteroid collided and formed Mare Humorum. The lava breached almost to the peaks of the central mountains in the crater center that are now just protruding above the surface. The crater's rim is heavily worn but still circular. It varies in height from just 200 meters at the south end to 2.5 kilometers high on the east wall, casting that nice shadow we see here. Gassendi A is the 20 or so kilometer wide crater that sits right on the Gassendi's northern rim, making the pair look like a diamond ring. And if seeing conditions are really good for you, see if you can detect this semicircular ring pattern here paralleling the southern wall, and notice how the land lifts up here. There's a rampart here up to this north rim supporting the diamond. Now, besides the double occultation just mentioned, there are 4 close encounters involving the moon this month. Tomorrow evening, you can watch the moon and the Pleiades rise just 6 degrees apart. And if you wait for the Hyades and brilliant Aldebaran to rise, by 7:30 p.m., you'll have a glittering scene worth photographing, if you can include an interesting foreground. This coming Sunday evening, Pollux, the moon, and Jupiter rise aligned. The crooked line becomes a straight line in a few hours as the moon drifts eastward between Pollux and Jupiter. While out enjoying the Leonid meteor shower, you can watch the moon rise very close to Spica. Maybe a meteor will shoot past the pair. And as the sky darkens outside the DDO on Saturday, November the 29th, you'll find Saturn rising just 4.5 degrees from the moon. Now, because of the long observing window mentioned at the start, we can see the constellations and stars from all 4 seasons. Here's the view to the south mid-month at the start of night. You can still catch Messiers and other deep space targets in the southern Milky Way, in the summer Milky Way. And in the south and southeast, the parade of the fall constellations is led by Capricornus, Aquarius, and Pegasus. The great Andromeda Galaxy approaches a zenith. Saturn and Neptune are found below Pisces. And by 11 p.m., the winter constellations rise into view. And if you stay up all night or decide to get up before sunrise, you'll see the spring constellations fill the eastern half of the sky. So you can see the constellations and stars from all 4 seasons. The only stars we cannot see are those in Scorpius and Libra. So that got me to thinking, if that much sky is visible this month, how many of the Messiers could one observe? To find out, I visited the Calgary Center's website and used this Messier Marathon Planner written by Larry McNish. I selected November 18, when the moon is nearly new and not sitting in the middle of the Virgo cluster. I chose Toronto as the site. I said objects had to be at least 10 degrees above the horizon. The sun had to be 18 degrees down, in other words, night. And as a result of these parameters, the not possible count came back at 12. In other words, 98 or 89% of the Messiers are. Now, a number of those Messiers pass very close to the zenith on November the 18th, giving us an opportunity to view or image them through the least amount of atmosphere possible. And here are some examples. At the start of night, around 6:30 p.m., open cluster Messier 39 can be found 9 degrees east of Deneb in Cygnus. At a distance of 825 light years, it's quite bright at 4.6 and can be detected by eyes alone as a faint hazy patch under a dark, no moon sky. It's an easy binocular target and best seen in the telescope under low power, since it covers a half a degree of sky like our moon. Its Trumpler classification is III2P, meaning the cluster is not concentrated towards the center. It has a small range of brightness amongst its stars, and the number of stars is poor, meaning up to 50. So here's a view showing the stars. They are quite the same in brightness. There's a few that are a little bit dimmer, and there's about 50 of them. 50 or under 50 is considered poor, the letter P. On the 18th, the trio of galaxies M31, M32, and M110 come within 5 degrees of your zenith around 2048. This close to the zenith, you're peering through the least amount of atmosphere possible. It's an excellent opportunity to observe or photograph the trio. M31, the Andromeda Galaxy, is a barred spiral monster with up to 1 trillion stars. M32 is a rare compact elliptical. Ellipticals tend to be the result of larger galaxies merging, and M110 is a more typical dwarf elliptical, more typical. Now, Charles Messier discovered Messier M110 back in 1733, according to the observing notes that he left behind, but for whatever reason, he chose not to include it in his list of fuzzy things that aren't comets. Instead, it was added posthumously in 1966. Messier's 104 and up were added to the catalog in the 1900s. Meanwhile, M32 and M110 are the brightest of 37 small galaxies, small satellite galaxies that orbit the Andromeda Galaxy. Astronomers at the Leibniz Institute for Astrophysics, Potsdam, have determined that 80% of the satellite galaxies lie in one hemisphere on the Milky Way side of Andromeda. Well, that's food for thought as you study this trio in binoculars. In this simulation from Stellarium, I set the atmosphere light pollution index to Bortle 5, hoping to mimic the sky over the Carr Astronomical Observatory. Now, if you are imaging these galaxies, take 2 hours of exposures, because that's when M37 comes to about a degree of your zenith. It's been coined the spiral galaxy, the spiral cluster, by Jeff Bondo, from what he perceived to be a spiral of stars in its makeup. Now, you can easily find the cluster in binoculars by scanning 1 degree above and slightly to the left of the halfway point between Algol and Almach. M34 is 1,400 light years away and estimated to be 200 to 250 million years old. It's over half a degree wide, and in telescopes, it's best observed under low power. And under a transparent dark sky, again, it can be detected by eye alone. Up to 80 of its estimated 100 stars can be resolved in a telescope. It's considered to be somewhat concentrated with a wide brightness range among its 100 stars. There's actually a recording that was made back on Monday. We wanted to avoid any internet interruptions that might occur. So I thank Andrew for recording this ahead of time. And what I'd like to show you now is this terrific eruption that occurred. I was mentioning in the video that the active regions that are now rotating into view, would they have bullets or would they be shooting blanks? I was asking. Well, they were definitely shooting real bullets. This is a class X1 flare. Let's see here. X1.8. Yes. Very strong flare. Now, this one's missing us, apparently, because it's not Earth facing. However, it's going to continue to rotate towards us. So, as I was supposing in the talk, you keep an eye on your favorite aurora forecast sites. We do have very high levels being predicted sometime during this coming week. So, definitely, we're in for another round potentially of some sunspot, some auroras overhead. So now then, I'm more than happy to, well, first of all, thank everybody for watching the show. And I'd like to ask if there are any questions.
Thank you very much, Arnold. That was a wonderful presentation. And yes, Betty, do we have any questions for Arnold from the chat?
Not tonight.
No questions?
But I love the hologram in the background. And you had amazing graphics.
Yeah, thank you. It's fun putting it together.
Yeah.
All right. Thank you once again, Arnold. Right. So we're just going to flip over to fun facts for a moment while we get ready for our next presentation. Oh, sorry. I've just been advised that we're, in fact, ready to rock and roll right now. So, ladies and gentlemen, I'd like to turn things over to Chris Vaughan.
Good evening, everyone, and thank you for having me attend the RAND meeting. It's been a long time since I've done a presentation. And I was inspired to hop on and give you a kind of an update on what I've been up to after seeing some of Frank Dempsey's observing reports at some of the RAND meetings. So I put together something that's kind of part memoir, part progress report, and actually there's a great part of it is going to be an invitation to join in the fun and to take advantage of some of the Toronto Centre resources, specifically the CAR Observatory that I'll talk about here a little bit later. So I'm going to talk about how it all started for me and where I got up to taking a look at the night sky. I'm going to cover the RASC visual observing programs that I've been working on, summarize with how it's going and where I've gotten with that. I'll then share a little bit about my equipment and my observing workflow. And, this is obviously a personal approach that you may find some, interest or benefit in seeing how I do things. And maybe you'd come up with your own process, but this is how I'll share with what I have been up to. I'll share some observing tips and general reflections on, what I feel after getting as far as I have, and talk a little bit about what could be next, what's coming. So basically how it started is I'm a lifelong visual observer, always been interested in the stars since as long as I can remember. And, outreach is fun. We all like to do outreach with the public, but I also like to be kind of out under the stars where I can hear the peepers and the coyotes howling in the distance and maybe catch the odd shooting star. And sometimes you get that warm breeze caressing you in the wee hours while you've been chilly all evening long. And heading over to the eastern sky and watching some of your long missed favorites return after many months away. So that's kind of the things I enjoy out of that. How did it all start? Well, back in high school, I got my first telescope. It was a Tasco 4-inch f8 reflector. It cost me, I think, $150 of my hard-earned paperboy money. Bought it used from a neighbor, and I still have that telescope. It's in a box since I moved up to Collingwood, but I still have it. I really enjoy keeping that model on hand. Flashing forward a number of years, by the time I got to be grown up and had a little bit of extra money, I was able to invest in one of those Meade light switch 8-inch Schmidt-Cassegrain telescopes. That's the kind that had the camera bolted to the bottom of it that could do a auto align for you. It had a robotic human being inside that could give you an audio tour of what you were looking at, all kinds of nice bells and whistles. And that was a wonderful scope. I added to that some nice radiant eyepieces and a nice 2-inch diagonal. And eventually I found I needed a motor focuser because it was a single arm telescope, not that well supported on both sides. So it really needed some stability added to it. So I went on and did that. This picture of me actually is all bundled up in the parking lot of the David Dunlap Observatory during one of our tailgate astronomy nights back in the day, long before COVID. Realizing that I wanted something a little more portable, I was keeping an eye on Kijiji and some of the aftermarket sites, and I discovered this little beauty in Waterloo. It's a Meade ETX90 RA, and the RA stands for Right Ascension, and that's because it's got a little clock drive in the base. It's not a go-to scope in this version of it, but it came with this tiltable field tripod that you could polar align by adjusting to the correct tilt, and then run the clock drive at the sidereal rate, and it would follow everything you needed to follow in the sky. Really narrow field of view though. f13.8 was the focal ratio. So it was wonderful for double stars and moon craters and planets and things like that, but far too narrow a field of view. So, and by the way, if you get anything like this, it's a great little telescope to start with. Make sure you get a dew shield, because these SETs and Macs had their glass corrector plates exposed to the elements, and you really need a dew shield on them to avoid frost or dew. But yeah, I found that narrow field of view was too narrow, so I wanted to widen up. I wanted to see the whole Pleiades or the whole double cluster. So I invested in a Celestron ED 80 millimeter Apo. It's a f7.5. This was actually a model that was being sold by Astronomers Without Borders for a while, so I was able to get that at a fairly nice price. All of this equipment is used, if I didn't already say that. Do keep your eye out on those Facebook Marketplace nowadays, or Kijiji. Make sure you widen your search field on Kijiji to all of Ontario, because you wouldn't want to miss out on a nice little gem, one town over, just because you didn't increase your search radius quite wide enough. So this is all around 2009, 2011 timeframe. That was right around the time I was starting to get involved at the DDO. Before that, I wanted to put that refractor on something, so I invested in a used Ioptron Smart EQ gem, or a German equatorial mount. I actually went and got a polar scope for that mount. I got really into aligning that. Not a very heavy scope. I wanted to use it for outreach and various things, but I just found it was a little bit too lightweight for that. So I needed something more heavy duty, and I came across this little item. This is actually a Skywatcher HEQ5 Pro mount that has sort of been Frankenstein monster upgraded by Dave Dev. So he sold me that model. It had some nice spreader stabilizers on the tripod, and I've been using that to this day. It's a really great rig for me to take to schools. It's very sturdy. I can do dual, white light sun and H alpha sun at the same time, and that sort of thing. And hey, there's a shout out to Blake Nancaro at one of the DDO volunteer days where we set our scopes up. Miss you, Blake. And yes, DDO 74-inch telescope. So I was able to migrate up to about as big as it gets. And I even got a couple of my observations for my observing programs done through that telescope. And of course, it was completely, manually operated. So no go-tos on the DDO telescope. All right, so where did all this happen? Well, this is a map of the GTA showing those red stars at the various places that I've been hanging out and seeing the night sky. Of course, my home originally was in Thornhill, down here south of the DDO. There's the DDO marked in Richmond Hill. A number of us often went off to Glen Major Forest, so in southern Uxbridge. You can see here that the sky isn't really as clean as we'd like it to be, but it was only 30 minutes away from my house in Thornhill, so it was kind of a nice, convenient place to go. And since we first started using Glen Major Forest, I noticed that the sky has deteriorated quite a bit because of the municipalities putting in a lot of those bright LED lights in public. And there's been also some industrial buildup along Highway 7 in that area as well. And then there's Long Sault Conservation Area. A number of us used to go out there. That gave us a nice, lovely dark sky. Not very wide open, though. I found it was a little bit cramped, especially if a lot of rascals were all having the same idea and getting out there. By the way, this map you're seeing here is basically a light pollution map. It's the VIIRS 24 layer from lightpollutionmap.info. It's the Visible Infrared Imaging Radiometer Suite. It's kind of a sense of how things are distributed in the way of light across the area. Well, of course, a number of us would take the drive up to the CAO, about 2 hours drive away from me for most of the time I was visiting. And then that basically grew to about 2.5 hours once all the development and construction started going on in Vaughan. And then there's 1 or 2 times where, especially during COVID, I have a bit of a story about that, where I went to Forks of the Credit. And even the Forks of the Credit, you can see here, is not super dark. Luckily for me, I actually also had access to this farm over in the west here. It's about 20 minutes south of the CAO near a town called Feversham. It's a family connection. And what's nice about the farm site is that it's actually at least 2 or 3 times farther away from the light domes of Collingwood and Blue Mountain. This little blob here I'm circling is the Blue Mountains. So I know that Collingwood gets a lot of criticism for its light dome, but I think Blue Mountain certainly has a lot to do with the effect on the skies at CAO. Anyway, 2 years ago, I moved to Collingwood. My wife and I wanted to get out of the big city. So now we live at the south edge of Collingwood, and I'm only about 25 minutes away from the CAO. So I've been spending a lot of time there. And luckily for me, we've got the option to get the road plowed into the observatory this last year or so. So it's a lot open for business for anybody that wants to come up and book a visit. So the story continued back in 2017 when Ian Wilband and Phil Chow invited me on an expedition to Australia and to attend the Oz Sky Safari in north of Sydney. And you can see in this picture here a lot of rascals you might be familiar with. We've got Charlene Norgrove, we've got Katrina in Slum, we've got Phil, we've got Tony Horvatin, we've got Ian Wilband, even Alan Dyer is there, for our rascal friend from out west. And this was an opportunity to take advantage of these gigantic, basically wooden Dobsonian telescopes, these obsession telescopes. The biggest one there in the back was, I think, 36-inch diameter aperture telescope. For that one, you needed to climb up a big ladder in the pitch dark and look through it, but it was breathtaking, the scenes you could see. But they had so many telescopes that a number of us were able to work in 1s or 2s. Using these big telescopes, 12 inches, 18 inches, 24 inches, and so on. And I really fell in love with them. They were equipped with, Argo Navis and sort of push-to equipment, but we were just using them unplugged because, truthfully, the hosts, they didn't want to keep troubleshooting all of us newbies that didn't know how to use the Argo Navis. So they just said, no, you got to use them unplugged. So we learned. And that was great. I took advantage of the southern skies and actually tackled a lot of the objects in the Caldwell list, which are 110 sort of showpieces of the sky distributed among both the north and the southern hemisphere. And I got some Messiers as well when I was down there. So that was April of 2017. And in the meantime, Stu McNair put this little beauty for sale on Astro Buy Sale, and I just prayed that he wouldn't sell it before I got home. So as soon as I got back from the trip, we made up an offer and we made it happen. So this is a 12.5-inch obsession, f5 focal ratio. It's got, as you can see, the wiring and mechanics on there. It's got an Argo Navis set up. It's got a Stellar Cat that provides me with go-to, with tracking, or I can just operate it as a push to, or what I mostly use it for is completely unplugged. I mean, I just have the power on it to keep the, the secondary mirror from doing up and things like that. But beautiful telescope, smooth, very wide field, very stable, very easy to use, and highly recommend, this sort of telescope if you want to really get serious, especially about the deep sky objects. So let's talk a little bit about the RASC observing programs. There are 9 programs, including 3 that are dedicated to the moon only, and they're actually listed at this website, rasc.ca certificate programs. And they range from extremely easy to extremely challenging. They are required that you do individual efforts. So even if you've got a partner or an observing companion that they both want to do the programs, you each have to do your own observations and searching and logging and that sort of thing. No prerequisites. You can complete them in any order. And actually that leads to a really interesting thing to think about. And that is to work on the programs in parallel, simultaneously. I'll talk more about that later. The Messier certificate program and the Finest NGC or FNGC, they both offer both a non-go-to version and a go-to version. So they'll recognize you whichever way you choose to tackle the program. What you want to do is record when you saw your targets, where you were, what you used, what the sky conditions were, things like that. And then, of course, your need to find the object, observe it, describe it, and then record and submit your logs. Make sure you're talking about how you star hop to a certain target, what size was it, what shape was it, its brightness, what field stars were in the field, its color, all kinds of things, its orientation, anything significant about the object. And nice for me, since I'm not a great sketcher, is that you're only required to sketch on a few of the programs for a few of the objects. So there's an example, just to prove that Chris Vaughan does indeed sketch when he has to. So what I'm going to do now is I'll just run through the my sort of timeline on those programs, kind of list them in order that I completed them in, and you'll see that it's not necessarily from easiest to hardest the way it worked out. You'll also see on each slide the equipment that I used, where I was, and I'll share some thoughts about each program that I think are pertinent. So starting off, most people will definitely start with the Observe the Universe program. It's great because it's open to non-RASC members as well. You can get a nice pin and a certificate, and it's got about 132 items, considering or including various constellations you need to recognize, bright stars you'll learn, various phases and aspects and features on the moon, seeing the planets, and then identifying and viewing certain deep sky objects and some double stars. It's kind of a sampler of the best of the various categories of things in the sky. What's nice is that you can basically use your unaided eyes for lots of it. Binoculars is sort of, add to that is much better, but you definitely don't need a giant telescope or even a big telescope to tackle this program. It's really excellent training. So it really sets you up and gets you started on your journey. They have a nice guidebook that you can find on the website under the Explore the Universe link. You don't need very dark skies for most of the objects. And there's lots of objects that are optional. And I highly recommend you do all the optional items, because really this is all about seeing the most you can, learning the most you can, and why leave anything on the table? Try it. Try to see everything you can. I think it's highly worthwhile and really makes it fun. Now, many of the items in this program can be applied to other programs as long as you've found them without help, without go-to, let's say, for example, and that you've logged them properly the way you would normally need to then later for the more serious programs. So for me, I started way back around August of 2012 and basically worked through it on a casual basis. I didn't really set out to do it on a serious, get the job done sort of mode. I just sort of eventually decided, well, I've got a lot of this observed. I might as well assemble it all and complete it. So it really took me up until around July 2019 to get it all finished. Mainly with unaided eyes, a little bit with that Meade L8, LS8, but lots with binoculars, an item or two with the DDO. And then eventually I got my big 12-inch job Stewart by the time I'd finished that program. So I wrapped it up with that. You can see the various places I was for that program. Now the Messier catalog. So the Messier certificates and pins are available to RASC members only. There's 110 items, obviously, consisting of different types of clusters and nebulae. Galaxies, even a double star is in the list. So 18 of the Messiers you will already have finished from the Explorer of the Universe. You're, almost 20% of the way there. Basically, you can get it done using an 80 millimeter telescope or larger if you've got a very dark sky, or a 6-inch or larger aperture if you're in the suburbs or a less dark location. You'll learn how to do star hopping and how to read star charts. And one of the little challenges of that program is to tackle, the 17 or so galaxies in the Virgo cluster in spring. And one of the tricks I used for that was I actually printed out basically a star chart, but it was a galaxy chart of that cluster of galaxies, and I inverted it to match the eyepiece view, so I could sort of hop from galaxy to galaxy rather than star to star. So that one took me about 4 years to get done on a semi-casual basis, and I did about the first quarter of it with my Meade light switch and various other things, and then once I had my big 12-inch job, I did the rest of it with that at these various places, including some in Australia, as I said, but a lot of them at Glen Major, Long Sault, and the CAO. Then they get the finest NGC, and this is maybe a little underappreciated or under noticed, less than it need to be. But Alan Dyer put this exceptional list of targets together, kind of a what to do next after the Messiers. So there are 110 of them. Again, the various clusters and nebulae. 58 of them are galaxies, so half the list is galaxies. And there's no overlap with the Messiers or the Explorer of the Universe, but you'll definitely find the skills you developed with the Messier program will definitely help you with the finest NGC. Similar difficulty to the Messier, so it's not especially harder than the Messier list, but it is best to have a 6-inch or larger telescope to finish it, to absolutely complete it, since some of the targets are a little bit more challenging. But yeah, of those 58 galaxies, 47 of them are in the springtime sky. So plan to head to CAO on a nice clear spring weekend, and you can tackle lots of these targets, at a relaxed rate. One of the fun things about this program for me is I was nearly finished it in 2020, the spring of 2020. I was nearly finished it, and I had a few items that I needed to get in the western sky. I needed a dark western sky, and for me, the only option I really had out of Thornhill was something like the Forks of the Credit. And so I packed up my big telescope and went off to the Forks of the Credit, only to find the whole park was gated and closed for COVID. And I had put the word out on the forum and ended up having to drag my telescope and set it up on an embankment across the road from Forks of the Credit. And Peter Richard came and joined me. We had a great time. And I got to look at Thor's hammer for the first time at Forks with Peter Richard. So that's kind of a fun thing we did, sneaking around and during COVID when perhaps we should have been at home. But for the rest of the year, I was able to get everything done and submitted and got that one done. You've seen a number of these. The background of this slide is Caroline's Rose, which is that nice big cluster up in near the Cassiopeia region. So don't assume that you have to start from scratch when you see these, even if you haven't, even though there is no overlap with the Messiers. Any of us that have been regulars at star parties and outreach will have seen some of these objects in the finest NGC already. In fact, there's the Rosette Nebula. That's one of the famous ones that you've probably seen. This one's is an image by Stan Noble that was in Sky News way back in the day. And here's the first page of the finest NGC list. You can see there are things in here like the Helix Nebula, which is spectacular. ET cluster, that's in Cassiopeia. You've got your double cluster in Perseus. Number of other things. Again, this is just 22 out of the 110, but trust me, there are all kinds of them that you'll if you haven't already seen them, you'll not have any trouble nabbing them as well. There's actually a nice gallery of the NGCs all photographed by John Myrtle at this website, but I would caution against looking at the objects before you've observed them for the program. One of the really rewarding things about these programs is describing what you saw, and then as you'll see it towards the end of my talk here when I show you my workflow, following up by reviewing what you saw and when using something like Stellarium. And it's really fun to be able to say, oh, I noticed that it was flat on the top, or it had a strange shape. And sure enough, when you do look at the object, you're confirmed. So you're sort of on the right track. Okay, now I changed gears a little bit because a lot to do with COVID and other things, but I decided I would tackle the Isabel Williams Lunar Observing Program, which was great because I could do it from home. I didn't need to have to book into the CAO or go off to Long Sault, or maybe I didn't know if the weather was going to be good and worth the drive, but suddenly it cleared up and I could just set up on my driveway and do a lot of work there. So the Isabel Williams program is a pretty extensive program. It's a pretty heavy lift. It's got 268 required objects, mainly easier ones that you can see with an 80mm telescope or larger. It's got 178 challenge objects that can be a little bit trickier to see, that you want a bigger telescope, mainly not because of the dimness, because of the aperture giving you the benefit of more light gathering, but the increased aperture giving you the benefit of resolution and detail. There are 19 optional observations, which are a mix of easy and hard, and lots of other things, moon phases, Pickering scale, all kinds of neat things around the moon, which by the time you're done, you'll really feel, like a moon expert. I basically did that starting around the COVID year 2020 and finished it around January 2023. Mainly it took a while because there were times where I needed to see certain phases of the moons at certain times and various events like that. A lot of it you can do with your eyes, but really the big telescope is a benefit, and you really will need to crank the magnification up on some of these features. So 226 or higher I had to use at times at various places here. Now, when you think about it, you really want your high magnification, which is going to mean you've got to have a good collimation on your optics, and you really need good seeing conditions. So steady sky, you want the moon to be a little higher, and remember that all the features in the Isabel Williams program, all of them are crammed into an area that's only a tenth the size of the Andromeda galaxy. So it sort of puts it in perspective for you. Here's one of my favorite things. This is the crater Clavius, which was the moon base in 2001: A Space Odyssey. I love this chain of descending size craters in that Clavius crater. So there's a typical setup for me on my little sort of courtyard in front of my house in Thornhill. Got my observing chair, my big daub, got some red lighting, and my logbook and so on, my eyepiece case. Obviously, I turn the lights off when I'm observing, but it's kind of fun. I used to have a little skunk that would wander by once in a while. We would have a little chat, and he would just wander off and not bother me, but it was good. Here's another alternate setup that I use for sometimes. This is a SkyMax 150 or a 6-inch Maxitov, and then I also was using these 10x42 Canon image stabilized binoculars for the binoculars program. We'll come to in a minute here. If you are interested in tackling the moon, I've got some tips for you, some ideas for you. One of the best things that I found, obviously a lot of people use the Ruckel Lunar Atlas. There's also, atlases that moon maps put out by Sky and Telescope and others. But this Lunar Field Atlas that was generated by Fred Days, I believe he's passed away by now, but he put that out a number of years ago. And he actually produced it in 4 orientations as a printable PDF. So you've got your correct image of the moon, you've got your mirror image of the moon for your refractor telescopes, you've got your inverted mirror image for your Dobsonian, and then you've got your inverted image for your others as well. So they're all covered, all 4 bases are covered. It's 2,244 objects indexed, all indexed, all printed. You might be able to find the PDFs at this archive link here. Here's an example of what it looks like. So if you're familiar with Ruckel Atlas, you'll see something similar. It's just that this one is going to have the charts oriented properly for your eyepiece view. Another app that I frequently used at the telescope was the Lunar Map and Lunar Map HD apps for Android. And this is screen caps from those apps below here. These are great because you could use different map images as your overlay. You could increase or decrease the amount of labels on the object and really zoom in and be able to pick off the fine features that you need to do. And you could flip the view to match your eyepiece as well. So that was great. One disadvantage was that you couldn't move the terminator off the current date. So basically, if you're reviewing or previewing, you couldn't change the date from today. It's great on a tablet. If you've got a tablet with a bigger screen, it's really nice to have. In terms of things like Sky Safari and Stellarium, just some thoughts on those. The nice thing about Sky Safari Plus or Pro is that you can show the moon at any time. You can set the date and time to anything you want. You can add field of view circles to match your eyepieces. I did find the labels are a bit too cluttered in the version that I was using, but it is great to have beside the telescope. And I also found that the Sky Safari moon map was a bit limited in resolution. Their forte is more the deep sky and stars, but the moon is there, but it's not maybe as good as some of the other apps. Stellarium for desktop has a really good moon resolution. When they upgrade the Stellarium, they tend to work on the moon included, so they do a lot of good things there. And you can add or subtract the names of objects. And Blake Nancaro and I did create bookmarks and observing lists for all the RASC programs, but not for the Isabel Williams program. So there's a link, there's a page on the RASCTO.ca website if anybody's interested in that. So there's an example of the Sky Safari moon view. Okay, next I tackled the Double Star program. Again, not to name drop Blake too much, but he's responsible for putting together this terrific list of 110 double and multiple stars. What you're looking at is a photo of Albireo. And, a lot of us have seen a lot of these stars already. So you're not really starting from zero when you do the program. You've seen Albireo. You've seen the trapezium in the Orion nebula. You've probably looked at Cor Caroli and the double, and all of these are in the list. So why not go ahead and start logging them more formally and putting them together? So I did that one from February 2021 to December. Again, a little bit of a lockdown. We weren't quite locked down as much, but during that time at home, I did go from time to time to other places and, maybe dabbed a double star or two while I was doing deep sky, but basically that's what I did then. And then I thought, well, I've done the Isabel Williams, but I should go back and do a completist thing. I'll do the Explore the Moon Binoculars program. That's only 40 items. They're mainly easy. They're mainly large. And I did those over the course of 2022. And I basically just used my Canon binoculars and sat in a chaise on my driveway and did that. So that was pretty easy. And then I switched to Explore the Moon telescope, 94 items. Some of the optional items in this program are pretty challenging, I'll have to say. Again, they're not required since they're optional. They're not required to earn their certificate. But I was able to get that whole program done in about 8 sessions during that block of time, mainly using that SkyMax 150 and times going up to pretty high power and doing that. One of the things that I found really tough on this program was to view the optional Apollo landing site. So there's the Apollo 15 landing site, which is really needed a good seeing and steady sky to see that. Okay, last couple of deep sky programs. David Levy put together a list of his favorite deep sky gems, he calls them. I've got about 154 objects. That's because we learned at one point that he was revising the list, even while some of us were trying to do the programs. So Blake, when he was the National Observing Chair, asked David Levy, could he please freeze the list? And so a few of us have a few extra beyond what we originally may have started off, the particular year we started. Many of these, again, are very easy, sort of similar to the finest NGC, and some are extremely hard, we found. About half of them are in the springtime sky. So there's one object called the double quasar in Ursa Major. That's a really tough one. In a lot of cases, I've seen the objects. I'm not 100% satisfied with my observations, and so I lead them as sort of complete and observed, but need a relook. So I definitely note things that I want to relook under maybe better sky conditions in my logs. So again, only with the big telescope. And I got about 66 of those at the CAO, and the farm, being the darker sky, gave me a greater number of them. So I was able to see some things that I didn't think I could see, when I first started into that. Deep Sky Challenge. So the Deep Sky Challenge objects, there's only quote unquote 45 of them, but they are designed for the challenge of the art. They're made for bigger telescopes. And a lot of times the notes will say things like, well, it's not that you saw it well, it's that the concept of what you saw is so special, how distant something is, or how difficult or how challenging it was. And I started that one back in 2018. So clearly, I've been running these programs kind of in parallel. You know, as the sky is good, I'll work on something harder. If it's not so good, I'll work on something easier, that sort of thing. Of these objects, I've got 2 left. And those are the only 2 objects left for me to finish all of what RASC offers. I got 31 of them done at the CAO and 11 of them done at the farm. And a couple things to note about the challenge and the Deep Sky Gems lists is that not all of the objects are in Stellarium or Sky Safari as searchable items, but the Observer's Handbook has all the coordinates. And if you know how to sort of set your coordinate in Stellarium, for example, you can log in and dial in where you need to be and make sure that's fine. Yeah, some of these were really hard, but so satisfying. So for example, some of them that you've already seen, the Pleiades nebulosity. A lot of us have been able to see the Pleiades nebulosity. That's in the challenge list. The Horsehead Nebula, it is possible to see the Horsehead Nebula visually if you've ever tried. I was really excited the night that I was able to trace out the Heart Nebula visually. I was able to trace out the Seagull and the California Nebula. And once you sort of get some success under your belt, you're really able to kind of march ahead and see that it's actually doable, you know? So again, I'm trying to encourage you to give it a go. You may not get to the end, but it's certainly the journey is a lot of fun. Here's one of them. I guess I missed one. I'm just going to put another picture in here, but I think I missed it. Okay, so that's the RASC program. What about what else you can do? Well, in the meantime, I thought, well, I've got time on my hands. I finished all the spring objects. What else can I look at in the spring with all these beautiful nights I had just 25 minutes from home at the CAO? So I started tackling the Herschel lists. So the Herschel 400 list is about 400 NGC objects that were selected from astronomers in Florida. And I'm still working on that. I've started it back. I got my first ones back in 2017. But there's the North American Nebula. It's on that list. So there's some overlap with the Messier objects. There are 14 Messiers in this list. And there's a bit of overlap with the finest NGCs and the Deep Sky Gems. So, hey, you've already got those programs. You've got a bunch of the 400s done. Keep going. Then there's a part 2. So you can actually do another 400 of them, mainly galaxies designed for slightly bigger telescopes. And again, I'm working on that list as well at the same time. So how's it going? Where have I gotten to? Well, at the moment, I got all the Moon and Double Star programs done. And as far as the Deep Sky objects go, I'm up to a life list of 778 found, observed, and recorded, all without GoTo. I've got 497 of those from the CAO and 146 from the farm. So yay, Blue Mountains, the dark skies of Blue Mountains, and especially that gem of the CAO for us Toronto Centre members. 2 of those Deep Sky Challenge objects left in the fall. Both of them are winter objects. I've got the Barnard's Loop around Orion, and I've got a globular cluster in Fornax, around a Fornax galaxy to get. And I'm hoping to get that soon. That's a spoiler for what I'm going to talk about at the very end. I've got only 18 of the Herschel 400 objects left to get, and I've got about half of the part 2s left to be done. So I'll be hitting 1,100 or so targets by the time I'm done if I can keep going. Okay, some thoughts on observing programs. You can do them in any order, but really explore the universe gives you a big head start. So make sure that you're, leveraging that investment in time over into the other programs. So work them simultaneously, especially you can make a lot of hay and a lot of progress during spring and summer. It definitely gets easier and it definitely gets faster the more things you look at. You can literally train your eyes to see more galaxies, faint nebulas and faint galaxies. I used to go observing with Ian Wheelban, and I would be shocked that he could see something and I didn't have a clue why I couldn't see it. And now I've learned that it's because he had that wealth of experience, practice doing it. You do pick it up. You do eventually start seeing things that you didn't originally. Nab the easy objects, then work on the rest as time permits. And really, I think it's helpful to make lists and to use apps so you can keep track of your progress. So tip, do the moon and double stars from home. No need to worry about long drives out to the country. The moon is higher in the springtime, and you do need lots of power and good seeing in a high moon to get some of those targets. As far as the deep sky goes, wide open skies are great. You know, if it's a bit of cloud over in the west, swing around and get something in the east. It's really nice to be able to do that. That's what Glen Major and CAO both offer us. Darkness and transparency, I think, are a bit more important, slightly more important perhaps than aperture is. So if you've got a smaller telescope, a 6 or 8 inch telescope, but you can get to a very dark site, you can do a lot with that. Don't worry about needing a giant telescope. You don't need to buy a lot of eyepieces. I basically work with 3, maybe 4 eyepieces for all that I do. You will want a good UHC filter. I prefer the UHC filter over the oxygen 3 filters. And if anybody wants to know the one that I recommend, I can share that a bit later on. When you're observing, take good long looks. You might need, for some of the challenge objects, you might need 20 minutes of staring in the eyepiece to pick up what you need to see. And if you don't see it, take a break, come back, try again. Maybe the sky has improved a little bit, or come back another night and try again. Definitely worth doing. You do want charts that match your field of view orientation. So Stellarium app and the Sky Safari apps can allow you to flip the view, flip the display to match your eyepiece. You don't want to don't be put off by stated visual magnitude. So if something, looks really, really faint in Stellarium, that may not be true. The magnitude values in Stellarium and the other apps are not always exactly right. So you may have better luck than you think you will. Don't assume you can see them. Give them a try, because your mileage will definitely vary. And basically challenge yourself on good nights. So there's our beloved CAO. This is me with my setup on the observing pad waiting for darkness. There's Bob, one of the more regulars lately at the CAO and the various pods. Look at that open sky that we got available to us. Okay, how do I tackle these things? Well, first of all, you want to plan what you're going to look at. And the first thing you want to do is check the moon phase. And when is the end of astronomical twilight? When does it get dark? Third quarter moon. And you can get beyond new moon, because a few nights after the moon has been new, it still sets rather early, as you can see here. By the time the sky is dark, that waxing crescent moon is going to be gone, and I'll be able to get started. Make sure that you check your weather and include the smoke, especially in the summertime. The smoke really wreaked havoc with us this summer. We didn't get a lot of observing done doing the thick forest fire smoke. I really like the Astrospheric app. I think it's kind of medium optimistic. So the clear sky chart for the CAO is rather optimistic, I find. Astrospheric tends to be a little bit less rosy, but fairly reasonably optimistic. And then if you really want doom and gloom, look at Clear Outside. It's usually a lot the least optimistic. So if you really want to be sure that you're not going to be disappointed, trust Clear Outside. But Astrospheric will usually benefit you. Every now and again, it'll disappoint you, but it does a great job. Okay, planning your setup. You've got target lists. So the Sky Safari will let you produce target lists and name them, and you can have various names for various sets. And you want to look at an evening what you're going to look at first, which is in the western sky, and then when you're going to leave till later when it rises a little bit higher. So it's pretty important to plan your night to take advantage of the hours you've got. Here's kind of a setup of my accessories. A couple of things that I'll just highlight here. The paracord. So my F5 Dobsonian, it benefits from a paracord, but I don't like putting extra glass in my optical path. So I tend not to bother with the paracord. I just live with a little bit of coma in my view, unless I really, really want the crisp stars at the edges. TeleVue PowerMate, I use basically all TeleVue except for this TMB 40 millimeter, which is my workhorse for finding my targets first. And then I use increasing magnification down from there. Another little tip I found are these USB powered heating straps for camera lenses and things like that. I use these for my eyepieces, and I just have a little battery pack that I plug that into, and I've got 3 levels of heat, and I can keep my eyepieces warm. These red laser goggles are really great. If you're at something like the CAO and you want to go inside and use the microwave oven, which has got a white light in it, throw on the red goggles and you'll keep your night vision completely preserved. And of course, we've got things like red lighting and headlamps. So when you're in the field, you want to start it by recording the sky conditions, where you are, what you're setting up with, what you're using, what the sky conditions are. Is anybody with you? Have you got some people there with you during the fun? And then what I do is I got this big tablet with Sky Safari Plus on it, and I put a red film. It's got a little case with a red film on it, and that way I can, I've got a nice big area of the sky to look at. And I start by enabling the Telrad rings in Sky Safari. I've got a Telrad on my Dob, so I just position the Telrad on the Dob with respect to the target on the sky chart using visible stars. Then I'll zoom in a little bit, and I've got the field of view indicators here. So some of these are Telrad rings, but this one is actually my Eyepiece field of view ring. So I can, once I find sort of a big object, in this case, I'm using Markarian's chain as kind of my jumping off point, then my target is really up here. I know that I can shift or slew in that direction. And by the way, at this point, you want to invert or flip your view to match your eyepiece. So for the Dobsonian, it's basically flip horizontal, flip vertical. Then we're really getting serious. We've got our object we think centered, and then we can match the star patterns around the edge. Another benefit of the Sky Safari, that you can press the tab, press the display in the upper left. It'll actually give you a selector that lets you add or subtract stars and add or subtract deep sky objects. You can sort of simplify or complex your field of view. So try your different powers, observe your target, write down what you see, or sketch. Some people would prefer to sketch. I like to sketch with words. So I note, where I aim the target, where I aim the telescope, what I star hop from and to. I note the stars that I landed on along the way, and then remarked on, what I thought about the object and what I noticed. And then once I'm finished, I get back home. Then I transcribe all of that into a spreadsheet, and I'm able to, fix typos and read my scratchy writing, especially if I'm there in February and my hands are barely working. But you can see here, I've got my object description, my log page, volume 3 of my log, the date and time, where I was, the telescope, what I saw, and that sort of thing. And I've got my, my sky conditions as well here. And, as the weather changes through the night, you can sort of make note of that as well. And then I really like to follow up with what I saw by reproducing what I did in Stellarium. And one of the little unsung great things about Stellarium, and it's actually a button that you need to enable, is there's a digital sky survey option button in Stellarium where you can actually flip from the plain sky with the stars to the DSS image, which allows you to bring up the backgrounds of the DSOs and more of the deep sky objects than are actually given photos in Stellarium to start with. So there's an example of doing that. I've also, this view of it also lets me mark the position angles on the celestial sphere, so that if I'm migrating to the lower right, I can indicate that that's east in my log, that sort of thing. Okay, what's next? Well, we've all got winter coming. It's already getting a little chilly up here in Collingwood. This is a view of last winter's GBO at the CAO. We had record snow here last winter. So one day I had to go in there and excavate myself into the GBO to get at my telescope. So winter's hard, your toes are frozen, your fingers frozen. If you're trying to write a log, you can barely write. So what do we do to avoid that? Well, we came up with this great idea that rather than wait for January, February, why don't we just get up in the early hours of the morning at CAO and look at the winter sky now? So we tried to set that up in late October. We got clouded out, unfortunately. And so we're going to give it another go. We've booked the weekend of November 14 to 16. It's open to RASC members. The idea is that we're going to, nap in the evening or in the afternoon, and then maybe head out with our telescopes midnight, 1 o'clock, 2 o'clock. On the 14th to 16th, the moon will start to come up almost at 3 o'clock, so 2:40 a.m. So we don't have a full night of moonless skies. But we want to go on the earlier weekend we can, the earliest weekend that we can. So if you want to join us, anybody's welcome that's a member. You can book space in the house. We have limited room in the house at CAO. You could bring a camper though if you want to, or anything in the heated that can keep you outside if you want to stay outside and sleep outside. You book the usual way. The fees are going to be waived for that weekend, and the road will be plowed in if there's any snow. Hopefully we don't get any snow by then. We are hoping or planning to have a backup weekend the following weekend, so November 21 to 23, and that will be a completely moonless night. So that's actually arguably the better weekend, but hey, we want to get the first try. So I'm hoping I can get my last two objects, in the wee hours of the morning on that weekend of the following one, and then I'll be done even before the snow flies. So come and join us. I stand on the shoulder of giants. I'm indebted to all the various mentors and friends and people I've observed with over the years in RASC and at CAO and other places. And I'm not going to read the list of names, but you can see there's plenty of people that you probably know in this list who I just hold really fondly in my heart. People like that we've lost, like Charlene and Blake, and just take advantage of the fellowship of RASC and take advantage of the gem we have in the Car Observatory. And I'll see you there. Thanks a lot.
Thank you very much, Chris. Thank you very much for a wonderful talk. Do we have any questions from the audience, Betty?
It's on. Yes, there are a couple of questions. Frank Dempsey asks, what is your favorite ultra-high contrast filter?
Okay. DGM Optics is the one that I have been using. I really like. It's not that expensive. I think I can find the link here if I have that right. Yes, here we go. I'm still sharing my screen. You can see it. There's the website, DGM Optics. And anyway, I've been using this a while and I really like it. So I would say give that a go. I mean, obviously other vendors make them as well, but I've had luck with that one.
Tony Harvatan asks, can you comment on which sorts of objects you find best respond to the use of the ultra-high contrast filter? Have you used general light pollution reduction filters?
No, I haven't used light pollution reduction filters. I have a filter slide in my big Daub, and that allows me to slot in or slide in an O3 and then the UHC filter. The UHC filter gives me a little more bandwidth, so I get a little more size to the nebulas and a little more brightness to them than the pure O3. In terms of what I really find helpful for that is, get your eyes nice and dark adapted and get that filter in there, and you can start tracing out beyond what you normally look at. So the North American Nebula, you start picking up the details. Seagull Nebula. I did the Gamma Cygni Nebula recently, which is very intricate, lots of little lobes and things like that. So it's really nice to be able to sort of trace these out and see the wonders that way.
Okay, it's not a question. Louis Rifkin says, thanks, Chris, for this very comprehensive report of your observing journey to date.
Appreciate it. Louis should have been on the list too. I miss you, Louis.
Okay, that's all for the questions. It was a great presentation. Thank you.
Yes, and I'm going to throw in a comment of my own or two here. If my little bit of experience, Chris was talking about doing multiple certificates at the same time. I strongly suggest that you do the Messier and the finest NGC at the same time. The reason being is that, especially in places like the Virgo cluster, you'll discover that when you're looking for one Messier object, you'll find two objects in the field of view. And in a lot of cases, that second object is a satellite or a pair, one of a pair of galaxies, and the other galaxy is in the finest NGC. So you might as well record them both.
Yeah, absolutely.
In any case, Yes, so thank you very much, Chris. And now, normally, this is the point where we'd have our president, Scott Masterton, step in and do the announcements. But unfortunately, Scott's having some computer trouble at the moment. So I'm going to do the announcements. Okay. Yeah, we're ready to go. Okay. So, just like to welcome everyone who joined us on YouTube. This is one of two types of meetings that we have. Normally, our recreational astronomy nights are in person at York University. But as I said before, tonight's is online only. And then 2 weeks from now, we're going to have one of our speakers' nights, which are always online only. For those of you joining us, please use the YouTube chat and ask questions, as others have already done so. And if you are a new Toronto Center member, please introduce yourself. Tell us where you're coming from. So, our speakers' night coming up on November 19th. Like I said, online only. Professor Charles Edouard Bouquer from York University will be talking about the structure, composition, and internal dynamics of rocky planets. 7:30 p.m., November 19th. A little bit of the abstract. The interior of the Earth, the planet we understand best, has been extensively studied over the past century, including seismic imaging, geochemistry, petrology, and geodynamic modeling. The question now is, do these processes also apply to other planets? How can we extend our knowledge of Earth to planets within our solar system and beyond? And can studying other planets help us learn more about Earth itself? So please join us online here on YouTube uh, 2 weeks from now. Coming up, our next recreational astronomy night, December 3rd, is also online only, and there's a very good reason why. We're still looking for a presenter for the Sky this month, but Dennis Gray will be talking about occultation, automation, and processing. And then immediately after our recreational astronomy night is going to be the annual meeting of the Toronto Center of the RASC. We'll talk about that in a moment. Normally at York University, we have weekly stargazing. We have stargazing happening immediate afterwards. So please, not next time, but in January, come out and join us in person at York University. Now, as I said, the annual meeting of the Toronto Centre of the Royal Astronomical Society of Canada is going to be starting at approximately 8:30 p.m. on Wednesday, the 3rd of December. The agenda, last year's minutes, and the slate of board candidates for the board of directors are all online. You must register for this meeting no later than midnight on the 1st of December. If you did not receive an invitation, these were sent out by email on Monday. And if you're a member of good standing, please contact the president at president@rascto.ca. Also, the anyone wishing to join the board of directors for the Toronto Centre, we now have nominations are open and are being accepted. Anyone who wishes to join us, the member must be a member in good standing, and the nomination form must have the signature of 2 additional members. The deadline for nominations is Monday, November 17th at midnight. Submit all nominations to our secretary at rascto.ca. And something new going on this year. So, under the new provincial laws regarding nonprofits, we now have to hold an election for the board of directors. In the past, we have simply put out a slate, and if no one else wished to join the council, we would just simply acclaim the slate of candidates. This is no longer acceptable under Ontario law. All board members must be voted on by the membership. So what was going to happen is that the election will be held online. The polls will be opening shortly after the end of the nomination period and will run for several days. We'll be sending out another email with the full details of the election shortly. So, events coming up in the Toronto area over the next few weeks. On Sunday, November 30th, we have Sunday sun gazing at the DDO from 12:30 to 1:30 p.m. Registration fees are as shown here, and as well, you can link either via the QR code or links can be found to register at rascio.ca. Saturday, December 6th from 6 to 8 p.m. Is Astronomy Family Night. The Blue Marble. Again, registration fees are as here, and links can be found on our website or the QR code. And then the DDO Speakers Night on Friday, December 12th, 6 to 8 p.m. Elsa Dong will be talking about atmospheric processes on Titan, a moon of Saturn, in the context of the Dragonfly mission. Again, registration fees are as shown here, and links can be found on our website or via the QR code. And as Chris mentioned earlier, the Carr Astronomical Observatory is open for members and is accessible all year round. Masking is optional. Please see the CAO bookings page for full details on our website. Just a reminder that it's membership season. You can renew your membership, or if you like what you've seen and you'd like to join us, you can sign up online at secure.rasc.ca. And also, the holiday season is coming up, so gift memberships are available. Contact the national office at mempub@rasc.ca. Just a reminder that the Toronto Centre runs on clean, renewable volunteer energy. We are always looking for people to help out. If you're a RASC Toronto Centre member, if you've got some spare time and you're interested in helping us, please drop us a line, volunteer at rascio.ca. As I stated, you must be a Toronto Centre member in order to give us a hand. One place that we're always looking for help is the David Dunlop Observatory. As you can see by all the friendly faces here, we're always looking for more help. And with that, I'd like to wish you all a very pleasant evening. I want to thank you all for joining us. Please follow us on all the forms of social media that we've got listed here. If you've been watching us live and you like what you see, please like and subscribe and hit the notification bell. Be safe and keep looking up. Good night, everybody.